Hi there everyone, I wanted to just go through a few problems on sequences and series that I think will be worthwhile having a look at. A little bit trickier, so rather than take all the time in class to explain them, I just wanted to go through them here. The first kind of question is this kind of percentage change thing. In this one here we've got a car that's depreciating in value by 5% each year. Car's bought for $45,000 and we want to find the value of the car 8 years after it's bought. Okay, there's a little trick in this one. Firstly, we've got to get the value of R correct. So here, if we're going down by 5% each year, subtracting 5% off 100% leaves us with 95% of the original value. So in this case, this is a geometric progression with R is equal to 0.95. Now, the first term here is $45,000. Okay, so here's the trick. That's how much the car is when we bought it. After 1 year, the car will be valued at $45,000 times 0.95, which is $42,750. Okay, that is what the value of the car is after 1 year. Now notice that is the second term in the progression. So after 1 year is the second term. If we go another year, the car will be worth $40,612.50. That's after 2 years, which is the third term of our progression. All right? So it's very important when you're working out the value of the car after 8 years to recognize that after 8 years will be the 9th term in the progression. Okay, that is critical for getting the answer right here. So the formula for your geometric series here, the nth term is a r to the n minus 1, and we're still going to use that formula, but we just need to recognize that here n is 9. The 9th term of the sequence gives us the value of the car after 8 years. So here we've got 45,000 times 0.95 to the power of 9 minus 1, or to the power of 8. So if we do that on our calculator, 45,000 times 0.95 to the power of 8, we get $29,854 to the nearest dollar. So it's just really important in that question there that you recognize that after 8 years is the 9th term. So any of these kind of questions where they're talking about a percentage change, the amount of money in the bank, all of those kind of questions, and you can do it using your geometric sequence formula, just be careful that you're getting the term number right. Okay, question 11 here is another one of these tricky ones in context, and you'll see some of these in an assessment. Ones like this that require you to go a little bit deeper, a little bit trickier. So in this one here, Penny's running every day. She's got two different plans. Now plan A, run for 2 minutes the first day, increase her running time by 30% each day. Hopefully you can see that plan A is a geometric progression where A is equal to 2 and R is equal to, increasing by 30% each day means R is going to be equal to 1.3. So 1 is where you start from, you increase 100% by 30%, that's 130%, or 1.3 is a decimal. And we're talking about what's the total time that she runs in 20 days. So part A is your geometric formula. The sum of 20 days is A 1 minus r to the n over 1 minus r. You put that in your calculator and you get approximately 1,260 minutes. That's rounded to 3 significant figures, or in this case to the nearest 10 minutes. Part B asks us to find the value of t such that the total time Penny runs for the first 20 days under both plans is the same. So let's look at plan B. Run for 1 minute the first day and increase her running time by t minutes each day. So plan B is an arithmetic progression. It's an arithmetic progression where A is equal to 1, the first day is 1, and increase her running time by t minutes. So the common difference is t minutes every day. So the first day she's running 1 minute. Let's say she increases by 2 minutes a day. That means the next day she will run for 3 minutes, the next day for 5 minutes, etc. So let's get an expression for the total time it takes under plan B. So that is the sum of 20 days. So that will be n over 2 times A plus n minus 1 times d, and d in this case is t. Okay, cool. So we can work that out. That's going to be 10 brackets 2 plus 19t in brackets, which is a bit more simplifying, is 20 plus 190t. So that's the sum of 20 days using plan B. So we want to find the value of t so that these things are both the same. The total time that she runs is both the same. So in other words, we want when 20 plus 190t is equal to 1260, which was our value from part A of the question. So solving that equation, subtracting 20, dividing by 190 gives us about 6.53, and in this case minutes. Okay, she's increasing the amount of time she'd have to run increased by each day would be 6.53 minutes. Okay, question 12. We've got an arithmetic progression with a first term of 18. The common difference is d. D is not 0. The first term, the fourth term, and the sixth term of this arithmetic progression are the first, the second, and the third term of a geometric progression with common ratio r. So we want to write down two equations connecting d and r and show that r is equal to 2/3 and find the value of d. Alright, this is a hard one to start getting your head around, so I like drawing this kind of thing out. We've got the first, 2, 3, the fourth, so the fifth one, this one, the fifth, and sixth term. So here's our arithmetic progression. These three terms, the first, the fourth, and the sixth, are actually the first, second, and third terms of a geometric progression. So what I'm going to do is get expressions for each one of these different terms, first, fourth, and sixth, and then see if we can work out what r is going to be, or show that r is equal to 2/3. Okay, so what is an expression for the first, fourth, and sixth term of an arithmetic progression with a is 18? So obviously the first term is just a equals 18, that's easy. The fourth term is a plus n minus 1 times d. And remember, we don't know what d is. That's what we're going to find out here. So the fourth term here is 18 plus 3d. That's this thing right here. And you could go through that process again, or you could realize that we're just adding on d to get that term there, and adding on another d to get that term there. So this is going to be 18 plus 5d. That's going to be the expression for the sixth term. So they are our three terms there that form the first, second, and third terms of this geometric sequence. So now, knowing what we know about geometric sequences, what we can say is we know that the ratio of the terms is the same. So when we divide the second term by the first term, we get r. When we divide the third term by the second term, we also get r. So I can write this equation out. 18 plus 3d divided by 18. That's what r is. We've times 18 by r to get 18 plus 3d. That's got to be the same as 18 plus 5d divided by 18 plus 3d. Okay. That is our value of r. So we need to now solve this equation. This is a bit of a mission. I would suggest now that you could get your calculator out. You certainly could solve it without your calculator. You could multiply both sides by 18 plus 3d and multiply both sides by 18, which would give you this expression. Okay, you could expand out the brackets. You're going to end up with an equation with d squared in it and solve it, and you'll find that your calculator should say d is 0 or negative 2. Now notice in the original question it said that d was not equal to 0. So this is clearly not one of the possibilities. So d is equal to negative 2 is the one that we want. And that answers that part of the question. The value of d, we're going down by 2 each time. So show the value of r then. So r is equal to 18 plus 3 times d divided by 18. And we put that in our calculator there. 18 minus 6 divided by 18 is 12 over 18, which is 2/3. It's now a simple thing to find the sum to infinity, knowing the formula. Sum to infinity of this geometric sequence. So the first term in our geometric sequence was 18. And r, we've just shown, or we're even told, was 2/3. So 18 divided by 1/3 is the same as 18 times 3, which is 54. Last part of this question, find the value of n such that the sum of the first n terms of the arithmetic progression is 0. Alright, so we want the sum of n terms to be equal to 0. We've got a first term of 18 and we've got a common difference of negative 2. So let's use the sum formula that says n over 2 times a plus n minus 1 times d, and we want that to be equal to 0. Okay, so that's just using the sum formula, and you can see that we're just trying to solve this to find what n is. So n over 2, we've got 36 minus 2n plus 2. So now it's just a matter of solving this equation. N over 2, we've got 38 minus 2n is equal to 0. Okay, you don't need to expand all that out because we've got this in a nice format where either this is equal to 0 or this is equal to 0. Clearly that is never going to be equal to 0. N divided by 2, because n is always a positive whole number. So that's not equal to 0. So really we're looking at when 38 minus 2n, when that is equal to 0. So add 2n to both sides and divide by 2 gives us n is equal to 19. And that's the answer to the question.